So guys, have you wondered how does a computer work? I mean, how does all the calculations inside the computer are going on? Well, a computer uses a very efficient technique called binary counting. Today we are going to answer some of those questions by converting while learning how to convert decimal to binary and vice versa. So let's get started. So converting a decimal number to a binary number is a very simple method. So now I'll teach you. We take let's say 29. So we want to convert 29 into binary number. So we know 29 is a decimal number. So going with the ladder method, we get 29 and drawing a ladder around it. I'm sorry. Yes. So we'll divide this 29 by 2. So by dividing 29 with 2, we get a decimal number. But we have to write it in a whole number form. So we get 14 because 14 times 2 equals 28. We have to write a number which is smaller or equal to the number we have provided, we are given. So yeah, 14 times 2 is 28, which is 1 less than 29. So we get 28 plus 1. So we get 1 remainder and we will write it here. Now again dividing 14 by 2, we get 7. Now this time we get no remainder. So there will be 0 here. Again repeating the whole process, we get dividing 2 by 7, we get a rational number, but we have to write it in a whole number form. So we get any number which is smaller than 7. So we get 6, which is exactly divisible by 2 in 3 times. So yeah, 3 times 2 equals 6, which is 1 less than 7. So we'll write 1 here. Again we will continue the same process. Now 3 is not divisible by 2, but 2, which is 1 less than 3, is divisible by 2. 1 times 2 equals 3, which is divisible in 1 time. So yeah, and we get 1 remainder over here. This area, this number, this series of numbers what we got here is what we want. So writing from this fashion from downwards to upwards, we get 1, 1, 1, 1, 0, 1. So this is the required number. So in binary we write 29 in the form of 1, 1, 1, 0, 1. So we can check that here. We can write 29 and we get 1, 1, 1, 0, 1. Ignore these all threes because yeah, this is just a number of times we are getting. So we get 1, 1, 1, 0, 1. So we are getting 29 in decimal form and we are getting binary form 1, 1, 1, 0, 1. So let's try with another example. For example, let's say 100. We have to convert 100 into binary form. Going with the same fashion, we'll use the ladder method. Actually, I call it ladder method. We divide 100 by 2, we get 50, which is exactly divisible by 2. 100 is exactly divisible by 2, so we'll write 0 over here because we have no remainder. Again dividing 50 by 2, we get 25. Again it is a whole number and we don't get any remainder. It's again 0. Again repeating the whole process, we get dividing 25 by 2, we get a rational number, but we have to write it in the form of a whole number. So we'll write here 12 and we get 1 as a remainder. Again dividing by 2, we get 6, which is exactly divisible. I should extend this ladder. Again repeating this in the same fashion, we get 3 and 6 is exactly divisible by 2, so we get 0 over here. And finally 2, we get 2 is less than 3 and 2 plus 1 equals 3. Again yeah, here will be 1 and here will be 1 also. So again writing this whole series of number from downwards to upward fashion, we get binary form of 100 equals 1, 1, 0, 0, 0, 1, 0, 0. So the binary form of 100 is 1, 1, 0, 0, 1, 0, 0. We can again check that over here, that 100 converted into binary, we will get our answer 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0. So go ahead and try solving the this question. Convert 98 into binary form. You can pause the video and do it yourself. Okay, so now we have to do that again in the same fashion. We'll write 98 and make a ladder. Okay, sorry, make a ladder around it. Dividing 98 by 2, we get 49. Now 49 we divide 98 by 2, which is exactly divisible. So we'll get 0 as a remainder, but 49 is not divisible by 2, or we'll get a rational number. Therefore we will divide a number which is less than 49, which is exactly divisible by 2. So 48 is exactly divisible by 2, and it will come 24, because 24 times 2 equals 48, which is 1 less than 49. Therefore we'll get 1 as a remainder. Again, we continuing the whole process, we get 0 over here. 12 is divisible by 2 in 6 times, so we'll get 0 again over here. Extending the ladder, we'll get continuing the process, we'll get 1 and 1. So again, writing this series from downward to upward fashion, we'll get the binary of 98 is 1 1 0 0 0 1 0. Again, we're gonna check that, because the decimal of the binary of 98 is 1 1 0 1 1 0 0 0 1 0 0 0 1 0. So we can check that we get our answer. Again, try solving. Give me the binary of I should say give me the binary number of 150. Go ahead and try it yourself. So repeating the same process as taught above, we'll write 150 and make a ladder around it. Sorry for that curve. Dividing 150 by 2, we get 150 by 2, we get 75. It is exactly divisible by 2, so we'll write 0 as there is nothing for the remainder. Again, dividing 75 by 2, we get a rational number, which is not, so we'll convert that into whole number. A number which is less than 75 and exactly divisible by 2, that is 74, and it is divisible by 2 in 3 and 37, because 37 times 2 equals to 74, which is 1 less than 75. So we'll write the remainder 1 over here. Again, continuing the whole process, we'll get a number which is less than 37 but exactly divisible by 2. It is 36. So we'll write 36 is divisible by 2 in 12 times, because 36 is 18 times, and we get 1 as a remainder. Again, continuing as doing above, we get 18. 9 times 2 equals 18, and we get nothing as our remainder. Again, continuing the whole process, we'll get 4, get 1, because 4 2s are 8. 4 into 2 is equals to 8, which is 1 less than 9. Again, continuing the whole process, we'll get 2 2 0, because 2 times 2 equals 4, which is exactly divisible by 2. Again, now this is for the last time, because 2 times 1 equals 2, and now we get nothing, because 2 is exactly divisible by 2. So the decimal of 150 is going as in the same manner. We'll get the 1 0 0 1 0 1 1 0. So the decimal of 150 should be 100 10110. Again, checking that, we'll get 150. We'll get 1001 1001 0110 0110. So this is right. Now we will try to convert a binary number into a decimal number. So for example, let us suppose we have a binary number, say 1 1 1 1, and we have to convert this number into decimal. This is a very simple process. We will write this as follows. We will multiply the same number with 2, and we will rise the power of 2 one by one. So first we have 1, we get 2 to the power 0 because this is the first digit, and we will start with 0, 2 to the 0th power, plus we'll go from right to left, plus this is 1 into 2 to the power 1, plus we again get 1 into 2 to the power 2, we get 2 to the power 3 into 1, sorry, into 1. So you can see a pattern over here. We will write the digits of the binary number here, and we will multiply that by 2, and we'll start by raising the power of 2 from 0 to the from 0 to whichever digits it goes. For example, we have 4 over here, so we will go over 4 times. So 0 1 through 3, we get 2 to the power 3 is 8, and times 1 is 8, plus 2 to the power 4 is 4, times 4 times 1 is just 4, plus 2 times 2 to the power 1 is just 2, plus any number raised to power 0 is just 1. So 8 plus 4 equals 12. Oh, sorry, 8. Wait a minute. 8 plus 4 equals 12 plus 3 equals 15. So in decimal we write 15, and therefore we write 1111 as 15 in decimal. We can check that over. Oh, sorry, we can check that over here. That 1111 equals, I'm sorry, this is decimal. Binary, in binary 1111 equals 15 in decimal. By this method we can convert any binary number into a decimal number. Now let's try and convert 1001101 into decimal number. So going with the same fashion, we'll start from here from right, and we'll go to left. So we get 1 into 2 to the power 0, because we are starting with the 0th power of 2, plus we get a 0, so we can just ignore it, or yes, we can write this for example so here we can write we will write 0 into 2 to the power to the first power, plus 1 into 2 to the second power, plus will again be 1 into 2 to the third power, plus again we get 0, 2 to the fourth power, plus 0 into 2 to the fifth power. I'm sorry if this is too small for you. I'll just magnify this. Again we can write that 0 0, we'll write plus 1 and into 2 to the sixth power. 2 to the sixth power is 64, plus 2 to the power 5 is 32, but 32 times 0, this whole thing becomes 0. So we will write plus 0. Again 2 to the power 4 equals 16, but 16 times 0 is just 0, so we'll write again this as 0, plus 2 to the power 3 is 8, 8 times 1 is 8, plus 2 to the power 2 is 4, times 1 equals just 4, and 2 to the power 1 is 2, but it times 0, so it will be 0. Again Here we get a 2 to the power, anything raised to power 0 is just 1. So we will write, and we have 1 in multiplication. So we will write plus 1. I'm sorry, plus 1. So we will get, wait a minute, let me just zoom it out. So yeah, here we get 64 plus 0 plus these 3 just remain as it is. So we get 8 plus 4, 13, 64 plus 13. We get 77. So the decimal number for 1001101 is 77. We can check that over here, that decimal of 77 equals to 1001101110101. Let me give an example. Say 001. Now go ahead and convert this into decimal number. So going in the same fashion from the right to left, we'll write 1 into 2 to the power 0th power plus 0 into 2 to the power first power of 2 plus 0 into 2 to the second power plus 1 into 2 to the third power plus 1 into 2 to the fourth power plus 1 into 2 to the fifth power. We'll get 1 2 3 6. Yeah, so we can also check that if we get 6 numbers in our binary number, so the last power of 2 will be 1 less than the total number of digits in our binary number. So we can check that there are 6 numbers, so our power is 5. Now we will add this. 2 to the power 5 equals 32. 32 times 1 is just 32, plus 2 to the power 4 is 16. 16 times 1 is just 16, plus 2 to the power 3 is 8, times 1 is just 8, plus 2 to the power 4 is 2 to the power 2 to the power 2 is 4, times 0 is just equals 0, plus 2 to the power 1 is 0, 2 to the power 1 is 2, times 0 equals 0, plus 2 to anything to the power 0 is just 1. So we can add all these and we will get 32 plus 25 equals equals 57. So the binary number for this so the decimal number for this binary digit will be 57. We can again check that over here, that the decimal for our binary number will be 57. So we can see that the decimal for 111001 is 57. So this is the method for solving such type of questions. So I hope by now you will understand how to convert decimal to binary and binary to decimal. So by now I think you should be able to understand how to convert a decimal number to a binary and vice versa. So if you found this video helpful, then please give it a like and subscribe to the channel for more such videos. Thank you.